Hi everyone. Today I will be covering the topic on UnityOne's capabilities for storage management. I would first like to showcase a quick synopsis of the capabilities under storage and the technologies and vendors supported on UnityOne. Firstly, let me show you how we discover storage devices in UnityOne. I've taken an example of NetApp storage for the purpose of demonstrating the capabilities. To add the NetApp storage device in UnityOne, users must click on Unity Setup and select Integration. Once that is done, they will be able to see the option to add the device. After clicking on Integrate, need to fill in the required details and submit to add the device successfully in UnityOne. Users will then be redirected to the device management, where they will see the device information and the actions that they will be able to perform. The function of storage management is to provide visibility of global storage devices in form of dashboards through which users can draw insights on storage capacity, utilization, health of devices, etc. to manage storage blocks efficiently, avoiding any downtime. Users can see their storage devices displayed in a window under Unity Cloud menu option by clicking on the Storage tab. It displays the list of the names, status, operating systems, management IP addresses, current storage utilization, tags, and multiple action buttons such as Manage the device, View the details, Raise a ticket, Alert notification, Monitoring configuration, Edit device details, and Delete device. Here, we are viewing the details of one such device cluster and we see the components of the cluster in the form of nodes, aggregates, SVM, volume, and LUN. This window shows the cluster details like version, IP address, overall system health, nodes, total disks, unassigned disks, aggregate disks, assigned disks, shared disks, broken disk, and others. Other information includes subsystems, storage utilization, top 5 aggregates, top 5 volumes, and top 5 LUNs. On clicking on the Nodes button, users will be able to view the individual nodes, serial numbers, IP addresses, HA partners, OS versions, and the status whether it's functional or not. Users can click on these individual nodes to view all the details such as status, uptime process, auto giveback, service process address, location, uptime, whether it's a HA enabled or not, and other. Apart from node details, there are other information such as storage capacity, top 5 aggregates, top 5 LUNs, CPU utilization, etc. To showcase the events generated by individual components of the cluster, users should click on the Events button and view the current total number of events generated in the cluster. There will be a list of each event with description, device name, IP addresses, device type, alert time, status, whether it's been acknowledged or not, source, duration, and recovery time. In the same way, users can view every trigger of a cluster by clicking on the Trigger button, which showcases the total number of triggers as well as the trigger name, severity, state, status, and mode. In the Statistic option, users will be able to see all the graphs related to the cluster. There are several parameters and time frame which can be selected to view a specific type of graph. Here, we are viewing the graphs based on transmit state, transmit packets, receive packets, and state. When clicked on Ethernet ports, users will be able to get the name, state, node name, type, enable details, and reachability of the cluster. Users also get an option to manage these Ethernet ports by creating support ticket. There's also an FC port button that shows the name, state, node name, physical protocol, whether it's enabled or not, and whether it's fabricated or not. These ports all are also manageable by creating support ticket by the users. On clicking the aggregates button, users get to see the individual aggregate components along with their name, type, total storage capacity, currently used capacity, and their available usage. Here, we have clicked on the specific aggregate to showcase its overview, which consists of details such as name, checksum, style, disk type, node name, number of plexes, plex detail, rate type, status, use capacity, available capacity, and other information. Users will also be able to see the storage utilization for this aggregate. When we click on the SVM component, users will find the total SVMs along with the names, states, configured protocols, volume counts, and management IPs. Moving on to the volume component, users will see the total number of volumes, names, SVMs, aggregates, states, types, total spaces, and available spaces, each of which can be managed by creating a support ticket. We have now clicked on the individual volume to see the overview. It consists of the volume details like name, aggregate name, state, type, language, total latency, Unix permissions, space used percent, snapshot reserve percent, etc. There is also a storage utilization information available. Finally, we navigate the logical unit number component of cluster by clicking on it and seeing the total number of LUNs, the names, SVMs, volumes, total spaces, available spaces, and states, which are all manageable by creating a support ticket by the user. We have now clicked on the specific LUN to get an overview of its details such as name, state, volume name, SVM name, usage, capacity, etc., and the storage utilization. This feature offers visibility to the users and showcases data centers, private clouds, virtual machines, alerts, virtual CPU, RAM, storage, the total number of devices, and type of devices which are currently being managed along with up, down, and not configured count, maintenance schedule, AIML event management overview with conditions and event reduction details, and ticket history from the ITSM tool integration. UnityOne also offers a monitoring view under View button, which gives a NOC view window to highlight all the storage devices with their statuses, current usages, and errors. Users can also add a new device here to enable monitoring. There is another system dashboard alongside NOC view, which is user based and enables them to view real-time graphs of certain devices. Here we are seeing cluster IOPS, forecast IOPS, throughput, latency, data compaction, aggregation volume deduplication, aggregate IOPS, aggregate throughput, and space full threshold percent. Finally, the last monitoring tab is the configuration window, which offers an overall configuration data, total number of devices, number of monitored devices, number of monitored disabled devices, and the number of non-configurable devices. Here, we can see a list of devices with their names, types, management IPs, SNMP IPs, SNMP versions, community strings, authentication levels, authentication usernames, and authentication passwords. Users can edit, disable, and delete any of these devices based on their requirements. UnityOne facilitates users with agentless and agent-based monitoring, which ensures continuous and real-time observation of the performance and the health of applications, resources, and services that are deployed across the hybrid multi-cloud. Here, we are demonstrating how to configure a cluster for monitoring, where the user must set a connection type, which are currently both agentless, SNMP and HTTP. For SNMP monitoring, details such as SNMP IP and SNMP protocol version V1, V2C, or V3 need to be entered. Based on the protocol version, which is v3 in this scenario, the users get to choose the SNMP string, auth level, auth username, auth password, auth algorithm, crypto password, and crypto algorithm. If the connection type is HTTP, then an IP address and predefined template needs to be entered. Finally, we activate the monitoring. After all these details have been set, we get a monitoring enabled successfully message displayed on the window after we are done. Once the monitoring is enabled and after the pop-up notification appears, the graph and create graph section will be enabled, where users will be able to see all the available default graphs and the discovered graphs after a short interval. Right now, we are viewing all the default graphs, cluster IOPS, cluster latency and throughput, their types, and a few actions of edit and delete. In the next scenario, we are seeing all the graphs that have been discovered recently. Total number of graphs has been displayed along with name, type, and actions. Users can click on Add Graph to make a new custom graph. They must enter details such as the name, select a type among normal, stacked, pi, and exploded, and then entering the items which they want to showcase in the graph. Here we have created a graph named IOPS matrices, which is a normal graph with 4 items checked successfully. After creating, we can search this graph by its name, and we are able to find it. In the graph window, we can scroll down and see the newly created custom graph. This feature is mainly used for IT operations, from where users can create their own triggers, and based on these, they can generate alerts to notify support engineers about the issue for a quick remediation. To create triggers, users can select predefined rules from the template and can upload their own auto remediation scripts through which the issue can be resolved automatically in real time. Here, we're showcasing the alerts window where users will find all the alerts related to the device. Total number of alerts, device names, alert descriptions, severities, and times have been displayed. In the trigger section, users will be able to see the total number of default triggers along with their names, severities, stats, statuses, modes, and other action buttons, namely disable, edit, and delete trigger. Users can create a trigger by selecting the Add Trigger option. Here, we are creating a custom trigger. We will fill in the name, severity mode, and rules. We have created a single mode trigger with a warning severity, selected a performance metric from the rules feed, defined a function, in this case last value, and then added a value at the end. Users will see a trigger successfully created notification once they are done. We are moving on to the AI/ML event management window under Unity Services section. Users will be able to see a dashboard with the total number of events, percentage of alerts, percentage of conditions, and noisy events list. Under Events console, users will see the total events, critical, warning, and information details. They can filter all these events based on parameters such as devices and status. Here we are seeing such filter events under warning and open parameters. Users can add rules by clicking on the button, and they will be able to see suppression rules, correlation rules, event types, and nagios. If user wants to suppress an event, they can click on the tab and create a rule with its name, condition, operator, and keyword. Here we have created a suppression rule for this demonstration. Next, we are checking out the correlation rules window, which is showing the rules predefined by the users. Rule name, condition, creator, date of creation, last update, correlator, description, status, and action buttons are displayed. We are now adding a correlation rule and filling up the details with its name, parameters, and specifying the correlator, whether it's topology, host, data center, or textual similarity. In the alert section, users will see the total number of alerts, DDoP events, noise reduction percentage, critical, warning, and information tabs. When clicked on the Show Suppressed button, the users will see the suppressed alerts. In this scenario, there is no such alert present. Moving on to the conditions page, users will see the tickets which are created and correlated events. In this scenario, we see that on selecting the same host correlation, there are 4 devices with IDs, counts, alert times, descriptions, status, sources, and whether alerts are acknowledged or not is shown. Users will find the details view and the list view option and will also see when the alerts are being generated. When users click on the ticket number, it will show them the details for the ticket such as alert time, source, host, correlator, status, severity, and others. Apart from this, users will also see a detailed activity log for the specific ticket. Lastly, there is an Analytics tab where users can apply various filters and see the top events, trends, noisy host, timeline, events by device type, graph, and others. There is also a list of suppressed and correlated conditions at the bottom of the window. This feature will give details on organizational ticket management in graphs and tables, for which users can derive insights on status, priority, response time, etc. In the UnityOne dashboard, users can find some of the tickets listed below once they scroll down. However, if they wish to see the details, they can select the Ticket Management button under the Support option. This window offers users with all ticket information with pie charts, third-party ITSM tool integration tabs such as ServiceNow, CRM, and Jira, and the list of ticket number, type, title, status, status reason, priority, created on, and updated dates. There are 3 graphs which categorizes the tickets by priority, status, and response time. There is a section where users can filter and see a specific type of ticket via some parameters such as keyword, status, date of creation, priority, and type. There is also a download option where one can get the required tickets in the Excel format. Here we are seeing a total of 4,944 tickets, and then we have downloaded the entire list in an Excel file. Here we are demonstrating a notification setup under Unity Setup option. We are creating a custom notification for some specific recipients. We are filling in group name, email addresses, alert type, which are info, warning, and critical, and the mode of notification, which can be either SMS or email. After submitting these details, the group has been successfully created. Users have the option to disable the notification, edit, or delete it. They can also delete all notifications at once by clicking on the button. Capacity planning. By applying OOB monitoring templates in UnityOne, customers can collect metrics associated with formatted, raw, replication, snapshot, virtual, deduplication, compressed, and space storage data. This data will be useful for capacity planning. CMDB. Configuration details for servers, network, storage devices such as vendor, model, capacity per storage, pool, mapped LUNs, allocated capacity per host, etc. are collected and displayed in UnityOne portal. Users can push the discovered data from UnityOne to any CMDB such as ServiceNow CMDB to create, update each instance. Consolidated health status. UnityOne AI can provide you a consolidated health status of all your multi-cloud environments in a single dashboard. Data deduplication and compression. UnityOne can monitor data deduplication and compression techniques applied on the storage models through out-of-the-box monitoring template to effectively capture storage space utilization. Fault detection and remediation. UnityOne monitors disk failures, regularly monitoring smart, that is, self-monitoring, analysis, and reporting technology or attributes, which indicate failures, network connectivity issues, storage controller failures, power supply failures, etc. This helps in fault detection and remediation, ensuring health and reliability of storage infrastructure. Alerting and notification. Effective alerting and notification strategies in UnityOne allows seamless storage monitoring. It enables IT teams to respond swiftly to issues, minimize downtime, and maintain the reliability of storage infrastructure. Auto ticketing. Integration with third-party ITSM tools such as ServiceNow, Jira, Zendesk, and Microsoft Dynamics CRM allows organizations to seamlessly integrate with their ITSM for auto ticketing. This automation enhances the efficiency of incident response, reduces manual intervention, and ensures a timely resolution of issues within their incident management framework. Thank you for watching this video. Reach out to our sales folks to set up a detailed demo of the UnityOne platform.